one bourbon, one scotch, and one bill. Hey, Mr. Bond.
Hello and welcome to the video on the substitution method. So, since integration is the inverse or the opposite of differentiation, there must be an opposite to the chain rule because, so for differentiation, we have what's called the chain rule, right? So when you have a composite function, you differentiate the outside function, and then you multiply it times the derivative of the inside function. So that's our chain rule. And so for integration, because that's the opposite, then we must have something that's contrary or contradictory to the chain rule, and that is there is something, and it's called the substitution method. Okay, so it's basically the opposite of the chain rule. Okay, so let's say let's go through the chain rule and see what it says. So let's say we have a composite function. So our outside function is a sine, and the inside function is x squared. So when we do chain rule and we differentiate, what we do is we differentiate the outside, so cosine, that's a positive cosine of whatever's in the inside, that just stays there, times the derivative of the inside, which is a 2x, okay? So we're left with 2x cosine of x squared, okay? So that's what we got from the chain rule, but now let's go backwards. So let's say we're taking this and we want to get back to the original function, so we want to integrate it. So now we're integrating 2x cosine of x squared dx, okay? So when we do this, we essentially basically stick whatever came out in the chain rule. So this came out of the chain rule because that is the derivative of the inside function, right? And we're going to stick it back inside that inside function, okay? So here's what I mean by that. So what we're going to do, so this came out of the inside. So this is our derivative of inside function. And so when we do the integration, then this derivative is going to come, it's going to basically collapse back into the inside function. So it's going to come out as a sine when we do the integration of the outside function, which is the cosine. Then we have our x squared, and that is just there, okay? So, and we also have that plus c just in case. Okay, so basically, this is what goes on, and you can always go back and check it. You can derive this to get back to your integrand, okay, and make sure that it works out. So, technically, how the substitution method works is that if our capital F of x is the antiderivative of lowercase f of x, then we have that capital F prime of x is equal to f of x, right? Because that's the definition of the antiderivative. So then we have the integral of f of u of x multiplied times u prime of x dx is equal to capital F of u of x and then plus c. So here we see something like what happened on the last problem, that example. So this u of x, that is our inside function. Okay, so this is the inside function because it's inside this outer function f of x, or f of something. And then we have the derivative of the inside. Okay? So when we do the integration, this kind of is stuck. We just kind of replace it. We mush it or collapse it back into, I think collapse is a good word. We collapse that back into the inside. So this is composed of both the inside function and the derivative of the inside function once we do the integration. And then this capital F, that comes from the antiderivative, right? So this is the antiderivative of that f of x, of that original lowercase f of x, okay? So when we, again, just a quick summary is that when we integrate the outside function, so this lowercase f turns into the uppercase f, and then what goes on with our u's over here is we're sticking the u prime of x, so the derivative of the inside, back into the inside function, which is just our u of x. Okay, so that's basically the substitution method in a nutshell. So what the substitution method, what it basically does is it's taking advantage, so it makes use of the u's, the middle function u, makes use of the u, or the also known as u of x. Okay? Alright, so this is how it works. So oftentimes it's called U substitution, okay? So U substitution, okay? So U substitution method, this is how it works, okay? I'm going to go through the steps of how we are to go about computing an integral using our U substitution. So here's our example. We're going to have the integral of 3x squared times a sine of x to the third, and then dx. Okay, so here's what we have. This is our problem. So first of all, what we're going to do, first step, is to choose something to be u. So choose a u, all right? And we're going to choose something, well, basically choose x terms to be u. Okay, so this is usually, no pun intended, usually, an inside function, an easy inside function. So in this case, what we're going to choose to be our u is what is inside. And it's usually, well, not all the time, but sometimes it's denoted by parentheses. You can just find it, right? So this is x to the third. That's what I'm going to make be our u. So u is equal to x to the third. So this can also be denoted as u of x, okay? All right, so anyway, so we just chose our u, so that's good. And you'll find that choosing some u's they make it a little bit harder. And there's usually a right choice for our u. Like if we chose this, that would not be good. So we're going to choose this x to the third right away, okay? All right, so the next step, so once you have chosen your u, what we're going to do is find what's called du. So this is the differential with respect to u by implicitly deriving, okay? And what I mean by that is we're going to take our function, or our u of x, also known as u, and we're going to take that equation and we're going to differentiate with respect to u on this side and x on this side. So we're going to get du is equal to 3x squared dx, okay? So we obtain this equation here, and now what we want to do, step 3, is solve for our dx, okay? So if we solve for dx, we get du is equal to 3x squared dx. So when we divide by 3x squared on both sides, divide by 3x squared. So then we get dx by itself. Dx is equal to du over 3x squared, okay? So now I'll show you where to go from here. So now that we have both that u is equal to x to the third and du is equal to, dx, hold on here, and that dx is equal to du over 3x squared, then what we're going to do with both of these pieces of information is plug in all of our u stuff that we can in for the x stuff. So like in to replace all of the x stuff in your integral. So for example, this is what we're going to do. So what we had was a 3x squared sine of x to the third and dx. So what we can do is actually replace x to the third with a u. Okay, so that's what we're going to do. So we're going to replace our x to the third sine of x to the third. So now we're going to replace that with a u, and we can replace our dx with du over 3x squared, okay? And see here how we couldn't replace that because we had nothing to replace an x squared or a 3x squared or anything like that, okay? So, but we do see that oftentimes things will cancel conveniently. So here in this problem, for example, we have a 3x squared on top and a 3x squared on the bottom that will cancel nicely, okay? So what we are left off with is a sine of u times du. Okay, so now at this step, we're going to, step 5, we're going to integrate like normal. Integrate like normal. Okay, so we're at the step of integral of sine u du. So when we integrate that, we basically just get a negative cosine u and then plus c, because that comes from the indefinite integral, right? We didn't have any limits of integration here. Okay, and also don't forget this plus c for our indefinite integral, right? And then number 6 is going to be finally here, we're going to replace or plug, well, I'll just say replace. Replace is a good term. So replace our x stuff back in for the u. Back in for the u spot. Okay? And by that, I just mean that we're going to say negative cosine of and not u anymore, but we're gonna replace our x to the third, okay? And our plus c, of course. And that's basically it. So this is our answer. And then I'm going to introduce a step 7, which is optional, but I highly recommend it. So step 7, this, like I said, it's optional, but suggested. So we're going to check if your answer makes sense. Check if your answer makes sense. So in this case, what I mean by that is taking our answer, so negative cosine of x to the third plus c. What we're going to do is derive it with respect to x. So we're going to take the first derivative. So that's going to be a it'll be a negative sine of x to the third. And from the chain rule, we're going to multiply times 3x squared. And this c goes away to 0. Okay, so we end up with a positive 3x squared times sine of x to the third. Okay, and that actually turns out to be what was originally in our integrand. So we are all good to go.
And then I sat there, getting high, mellow, knocked out.